Evaluate limit as x tends to 0 of 1 minus cosine x all over x squared plus 2x. If we directly plug in x equals 0 here, we get 1 minus cosine 0. Cosine 0 is 1. You can check in your calculator. And 1 minus 1 is 0 on the top. 0 square is 0 plus 2 times 0. Just 0. So 0 on the bottom. So we get 0 over 0. That means if we graph this function, there is a hole at x equals 0. That means limit still exists. So one way to evaluate this limit is factor the top, factor the bottom, just manipulate and cross out the 0 making factor, which is x. But that's not the case here. We can factor x out from the bottom, but it's a trig function. Cosine x is together, okay? So we cannot do that, but we just learned a new way to evaluate these limits. As long as we get 0 over 0 or plus minus infinity over plus or minus infinity, we can use L'Hopital's rule. So I'm applying L'Hopital's rule because I have 0 over 0 for this limit. That means L'Hopital's rule is applicable. So I'm indicating that, writing LH. So L'Hopital's rule is that limit of this fraction is same as limit of the following fraction, where we take the derivative of top on the top and derivative of bottom on the bottom. Okay, it's not like quotient rule. So let's find the derivative. Derivative of 1 is 0, don't have to write, or we can write, okay, minus. Derivative of cosine is negative sine x, and minus and negative, that is plus. On the bottom, derivative of x squared is 2x plus derivative of 2x is 2. Let me simplify. Note that these two fractions are not the same. All we are saying, the limit of this fraction is same as limit of this fraction, okay? 0 does not count. This is plus, so sine x on the top over, we can put parentheses around, 2x plus 2. Let's plug in here sine 0, which is 0, okay? On the bottom, 2 times 0 is 0 plus 2 is 2, 0 over 2. Okay, it's not 0 over 0. We don't have to use L'Hopital's rule anymore, because 0 over 2, I can simply write like this, and 0 divided by 2 is just 0. Okay, so the final answer is 0.